You are listening to The Vocal Technologist. Spoken Tech for your ears.
Welcome along to Vocal Technologist. Today, we're jumping into our Product Thursdays exploration, looking at some really smart strategies for, anyone building data-driven products.
Yeah, some great stuff today. We've got data warehouses, AI architecture, even getting down into the details of database performance.
Exactly. And we're going to unpack how some companies are getting really clever about cutting costs and boosting performance in ways you actually learn from. Okay, so let's kick off with this Fiverr example. Their engineering team rebuilt their data warehouse using dbt, Cloud, and Prefect.
Right.
The big idea seems to be this dynamic pipeline using the dbt Discovery API. It only runs the specific bits it needs to, not the whole massive thing every time.
That's the core of it. It's incredibly efficient. It means much faster data delivery and way lower compute costs.
So how did they achieve that? That sounds, well, complicated.
Well, what's fascinating is the kind of surgical precision they built in.
Yeah.
They actually created a custom fast API service just for checking test results, quality control, basically. And they've got this smart run status table. It makes sure each little sublineage only runs once per cycle, whether that's daily or, even more frequent.
So no redundant runs.
Exactly. And for doing clean backfills, they set up a whole separate prod offline environment, plus a dbt macro that dynamically tags models. It's really well thought out.
That level of precision is, wow. It makes you think, doesn't it? How you could apply that kind of targeted approach to your own data flows and, frankly, your budget.
It definitely does. And, that idea of breaking things down, it links nicely to our next topic.
Which is?
Avoiding the AI monolith. This is a big one.
Yes, I've seen this happen. AI projects kind of accidentally create these tangled webs of agents, right? Tightly coupled, hard to test, impossible to scale sometimes.
Precisely. The key, really, is thinking about microservices principles, but for AI. Create independent modular agents. Clear interfaces between them.
That makes sense. Treating generative AI like, well, proper software engineering projects, not just hype.
Exactly. It's iterative development.
So if you break it down like that into these modular agents, observability must become absolutely critical, right? How do you track what all these little pieces are doing?
You nailed it. Observability is key. We saw that example from Definite's AI agent. They're using something called Pydantic Logfire.
Logfire, okay.
Yeah, and it captures everything. Every model call, every tool call, token usage, errors, trace IDs, the whole 9 yards.
Comprehensive.
Very. But interestingly, they found Logfire's own dashboard wasn't quite flexible enough for what they needed.
Oh, so what do? They
stream all those logs into Duck Lake, allows them to build totally custom dashboards and alerts tailored to their exact needs.
So the lesson is build modularly, but make sure you can see what's happening. Deep observability for resilient AI systems.
Yeah, absolutely critical.
Yeah.
Especially when you're moving away from those monolithic structures.
Yeah.
You need that visibility.
Right. Okay, so architecture and observability are crucial, whether it's fancy AI or the database sitting underneath it all, which brings us neatly to PostgreSQL.
Good old Postgres.
We had some interesting points on optimizing it. First off, automatically rebuilding PostgreSQL indexes. Apparently, it's hardly ever needed.
Yeah, that's a common trap people fall into.
Yeah.
Setting up scheduled rebuilds.
The key metric to watch is avglyph density, right? Using pgstat-index. You only really need to rebuild if that density stays low and keeps dropping, or maybe if fragmentation is really messing up your range scans.
Exactly right. Don't just rebuild blindly. Understand why you might need to. It saves resources and often avoids unnecessary overhead. Use the tools, understand the metrics.
Makes sense. And related to that, for JSON-B data specifically.
Ah, yes, JSON-B. JSON indexes are your friend there.
Key and indexes, right.
They're fantastic for searching inside that JSON-B structure. Key value pairs using containment queries like the add operator or just checking if a key exists. Super fast for those specific tasks.
But there's a catch.
Well, yeah. GIN indexes do have a higher write overhead compared to standard B-tree indexes.
Yeah.
So it's a trade-off. You need to consider your workload. Lots of reads, needing fast JSON searching, probably worth it. Lots of writes. Maybe reconsider.
Good context. It's all about understanding the why and the trade-offs, not just applying rules blindly.
Precisely. Informed decisions.
Okay, we've covered quite a bit today here on Vocal Technologist. Some really efficient data pipeline strategies, smart ways to think about AI architecture, and some practical database tuning.
Lots to think about.
Definitely. And before we wrap up, here's a final thought to chew on, sparked by Conway's Law. It basically suggests that how your teams communicate, well, it directly shapes how your systems and your data are designed.
Well, that's a fascinating angle. Siloed teams, siloed data.
Pretty much. If your teams aren't talking effectively, you might just end up with fragmented, inconsistent data models almost inevitably. It's baked into the structure. So the closing question for you is, how might taking a fresh look at your team's communication actually change the data products you're building? Something to ponder.
Definitely something to think about.
Thanks for tuning in. Keep exploring, keep learning, and we'll catch you next time.
Spoken Tech, for your ears.